Hi, in this video we're going to look at the topic of fractions again, and this time we're going to look at adding and subtracting fractions. You might hear some strange noises in the background this time. I'm actually sat in a strange location, sat in the car in the rain doing this video, so I apologise if there's any strange background noise. This is a GCSE foundation topic, and as ever, if you want more information you can contact me at Mr_G_Walton on Twitter, or you can follow our school account at Tupton Maths. Video, what we're going to aim at doing is looking at adding and subtracting fractions where the bottom numbers are the same. So this is the first thing we're going to do. Then we're going to look at adding and subtracting fractions where one of the bottom numbers is a factor of the other. This is a key word here, factor. Make sure that you know what this means. This is a really key word, especially for all of the foundation topics. And finally, we're going to be able to add and subtract fractions where both the bottom numbers need to be changed into something else, and we'll call that a common multiple. If you're not sure how to do that, you need to go back and watch Fractions 1, the video Fractions 1, and that'll explain how you change a fraction into a different equivalent fraction. First of all, let's have a look here then. So we've got this idea of working out 7/10 minus 1/10, and it says give your answer in its simplest form. Now, the thing to spot when we're doing any work on fractions is this number at the bottom. Now, your classroom teacher may have said that this is called the denominator, and the number on the top is called the numerator. I don't want you to get overly worked up about the names of these things. I'm just going to talk about tops and bottoms. Okay, it's not going to cause a huge amount of difficulty for you as long as you can do this process. Let's not worry too much about the terminology. I'm simply going to think about the bottoms. Are the bottoms the same? It's really important, this part. I'm going to draw a little picture, and I'm going to use this circle here to help me. So imagine that this is the whole. I've got this circle here, it's the whole thing. If I do this, but cutting it down in the middle, we've now created two parts. Okay, so this we can now say is 1/2 over here. Okay, fair enough. What if I cut it in half again? Well, I've now got 4 pieces. This bit that I'm colouring in blue is representative of 1 out of 4 pieces. These 4 pieces are equal, or at least they should be. These should represent equal pieces, and you can think about it in terms of cake or pizza or whatever your favourite circular food might be. And I can continue to do this idea of cutting things up into various kind of slices. I'm going to do it again. I'm going to cut each piece in half again, and now I've cut it into 8 equal pieces. 8 equal pieces, and this piece here is 1 out of 8, because I've got 8 equal pieces, and here is one of the slices. If I had more than one of them, I don't know, let's go with 2 or 3 here. 3 of these slices, it's not 1/8 anymore, it's 3/8. I've got 3 of something that's the same. And this is key. This idea of having 3 of something, whether it's eighths or quarters or whatever, as long as we're talking about the same thing. If I have 3/8, as I've got here, if I add 1 more eighth to it, because I'm dealing with the same thing, the same sized object if you like, I've now got 1 extra. Now, that means I've actually got 4 of these pieces. 1, 2, 3, 4. And these pieces, these things, are called eighths. So I've now got 3/8 plus another eighth, which means I've now got 4/8. Okay, so when we're looking at these fractions, if the numbers on the bottom are the same, we can just simply look at the tops and deal with the tops. So in this first question where it says 7/10 minus 1/10, then I've got 6/10. I've not had to do anything else. I've not had to take numbers away from the bottom. The numbers at the bottom stay the same. Okay, so I'm not going to add them. I'm not going to take them away. It's only the numbers on the top that I have to do this with. Now, reading the question, it says give your answer in its simplest form. That means cancel down. And again, if you're not sure how to cancel down, watch the last video, fractions 1, and that'll show you how to do it. In this case, 6/10 cancels down to 3/5. I can divide the top and bottom by 2. Right, let's look at the next question then. It says work out 4/5 plus 1/10. Now in this case we've got an issue. The numbers on the bottom are different. You cannot, even though you are really tempted to, you cannot just add the tops and add the bottoms. You will not get the right answer. Okay, I can't stress this enough. Don't add the tops and add the bottoms. You can only add or subtract fractions when the bottom number of each fraction is the same. Okay, let's look at these then. I've got a 5 and a 10. I'm going to have to convert this first fraction here into tenths. So it's currently fifths. I'm going to have to convert it into tenths. In the last video, we saw how we could do that. We can scale them up. What can I do to multiply, or what number can I multiply 5 by to get to 10? Well, it's 2. I'm going to have to multiply the top and bottom of my fraction 4/5 by 2. That's going to give me 8/10. Now again, 4/5 is equivalent to 8/10. I've not done anything in terms of changing the size of it at all. The numbers on the top have got bigger by 2. The number on the bottom has got bigger by 2. These things are the same. And if I was able to draw a little picture to kind of represent it, then here's my circle. Not a very good one. If I show it in terms of fifths, I'll see if I can do this as neatly as I can. Okay, you've got to use your imagination a little bit with this. All these are the same size. Okay, so these are all fifths. 1, 2, 3, 4, 5. If I have 4 of them, so let's shade it in blue. So here's 1, 2, 3, 4 of them. Here are my 4/5. Now, if I'm turning it into 8/10, it means that each of these pieces has been cut in half again to turn it into 10. Here we go. I've now got 10 pieces. How many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. I've not shaded any more blue in. I've still got the same amount of blue as I had before when it was 4/5. It just happens now that I've got 8 pieces, but each piece is half as big as it was before. That's all we've done. Okay, let's get back to the question. I've converted 4/5 into 8/10. I'm now adding one more tenth to it. The numbers on the bottom are the same. It's almost like saying I've now got one more piece over here. I've now got 9/10. Brilliant. Okay, this is key. If you can't change your fractions into an equivalent fraction to be able to do this, then you must watch the previous video. Let's have a quick go at this example then. At this point, you might be feeling really confident about this, and if so, have a go now. Otherwise, just keep watching and I'll show you what to do. A quarter needs to be converted, or at least one of these fractions needs to be converted so the bottoms are the same. Easiest way to do it is to convert a quarter, the 4 here, into an 8. I can do that again by timesing by 2. So I'm going to use this idea of timesing the top and bottom by 2, which is going to give me 2 8s. 2 8s plus 5 8s is going to give me 7 8s. Notice I didn't add the tops and the bottoms. I only add the tops, and I only add the tops when the bottoms are the same. I can't stress this enough. This is absolutely critical to when you're working out fractions. Do not ever, ever, ever add the tops and add the bottoms. You only add the tops. Let's have a look at another example. This time I've got 3/4 here and 2/3 here. Now, immediately I'm thinking I can't turn a 4 into a 3 by timesing it by something, and I can't times 3 by something to get to 4. It's certainly not a whole number, so I'm kind of stuck. I think I'm going to have to multiply each fraction by something to enable me to get to this idea of equivalent fractions. Okay, now easiest way to do this is to multiply the two bottom numbers together. That's going to give me 12. So I'm going to rewrite each fraction to be out of 12. Remember, I'm doing a takeaway here. And the easiest way to do this is to say, okay, let's think, what can I times 4 by? Choose a different colour. What can I choose 4 by to get to 12? What can I multiply 4 by to get to 12? Well, I can multiply that by 3. Everything that I do to the bottom, I have to do to the top, so 3 times 3 gives me 9. So 3/4 is the same as 9 over 12. It's just 3 times bigger on the top and 3 times bigger on the bottom. Brilliant. What can I times 3 by to get to 12? Well, I can times that by 4. And again, whatever I've done to the bottom, I've got to do to the top. So that's got to be 2 times 4, which is 8. That gives me 9 over 12 and 8 over 12. The numbers on the bottom are the same, which means I can now just deal with the tops. 9 take 8 is 1. 1 over 12. Good. Right, this is one for you to have a go at. It says work out 3/4 minus a fifth. Think about how I just did that last one. If you need to go back and have a look, by all means do so. But pause the video, have a go at it, and then play it again when you're confident that you've got an answer, and we'll see if we agree. If you can cancel this down to the lowest, to the simplest fraction, please do so. If it doesn't cancel down, then just leave it. Okay, let's have a look then. I'm going to think about what I can type, what number 4 and 5 can both be as a common multiple. Easiest way to do it is times the two together. So I'm going to rewrite them over 20, because 4 times 5 is 20. And then each time I'm going to think, what can I do this side, and what can I do this side? 4 times something is 20. Well, 4 times 5 is 20. If I times 4 by 5 on the bottom, here, by 5 to get 20, I've got to times the top by 5 as well, to make it equivalent, to make sure I haven't changed the size of the fraction. 3 times 5 is 15. Let's look on the other side. 5 times something gets me to 20. That's 4, and I've got to do the same at the top. 1 times 4 is 4. Now, I've got this point where my bottoms are the same, 20 here, 20 here, so I can just do the sum, 15 take 4, which is 11. 11 over 20. I know that 11 over 20 doesn't cancel down. And the reason that I know this is by looking at 11. 11 jumps out at me as being a prime number. Okay, another one of these key words that we use all the time. I know that nothing else goes into 11 apart from 1 and 11. So there's no point in trying to simplify it down anymore, because I know that 1 goes into 20, but 11 doesn't go into 20. And therefore, the only thing that I could divide 1 and 20 by in terms of cancelling down, divide 11 and 20 by to cancel down is 1. And that makes no difference. So 11 over 20 is in its simplest form. Right, at the end of the videos I like to give some revision card notes, and the most important bit I've put at the first: never ever just add the tops and add the bottoms. It's so tempting. I see pupils do it all the time, and you're never ever going to get the right answer. If you can find an example where you get the right answer, then please leave a comment on the video, but I will be really surprised if you get asked a question in an exam that leads you to be able to use that method. Only add or take the top numbers when the bottoms are the same, and you might have to somehow make the bottoms the same by using the idea of equivalent fractions. Let's see if we can give you a quick example that you could write down. Let's say a third plus a quarter. You'd have to write them both over something. So both over 12. What can I multiply this by? What can I multiply this by? Well, 3 times 4 on this side, so we've got 4/12 times 3 on this side, 3/12. Remember, we're adding, so my final answer is 7/12. And you could do what's called annotating, so you could write a few little comments about how we've changed it to this, what have you done to change from here to here, why you can do this, and maybe you can do yourself a little picture like with a circular piece of food that shows how it works. Okay, as ever in these videos I always wish you good luck. That's because I mean it. So good luck, and I'll see you soon. Bye.